We'll proceed in summation to integral calculus. Okay, we are pursuing mind-blowing discussion. Summation to integral calculus means how I can divide my problem into n different parts and solve part by part and then sum it. That is a summation. If we believe, if we believe that this summation may not be perfect, if we believe that this summation may not be perfect, then we can go for the n number of parts n tends to infinity. And then summation would turn into integral calculus. If I am summing n different parts, this is typically described as sigma. Sigma means I am summing n different parts. For any reason, if we believe that n different part is not perfect, it should be more than that, then n tends to infinity. Summation of n different parts, where n different part n tends to infinity, then in that manner we have to convert this summation into integral calculus. Integral calculus is also a summation where summation of different parts. Same thing. Sigma means summation of n different parts. Sigma I equal to 1 to n and ith part. If I add all the ith part, n part, then this is called summation. Summation of different part is sigma. Same thing. Integral calculus, a limit from begin to end, and then fx dx. Fx dx. Limit is also summation mark, only up, how you can say like that. Yes. Integration limit, if we see from other perspective, it is summation only. Okay, what are the different facets of integral calculus? One integral calculus facet is if I have a function over x, if this is x-axis, where x-axis went? Paste here. Okay, finally got good. Okay. Okay, so concept is that we are talking that what are the different facet of integral calculus? If I am talking about integral calculus, what are the different facet of integral calculus? If I take axes, okay, so this is x-axis and this is y-axis. If this is x-axis, we can call this axis as function over x-axis, y-axis. One facet of integral calculus is if there is a function, if there is a function line, if there is a line, there is a curve. If there is a curve like this is function over x, curve like this. If I say fx dx, hope this part is not This part, right hand side part is not there. Okay, if I say this is a curve and this curve equation is fx, this is x-axis. Fx dx means area underneath it. From where? Left limit, right limit where? That limit I have to place. x1 to x2. Whatever the area comes in between, that is fx dx. I believe it is understandable. That is fx dx. Fx dx is area underneath it. Okay, area underneath it. This is the one form of saying fx dx limit x1 to x2. There is another form also. People can think from this only. This as a repeated summation, sigma. What is sigma? One sigma we are talking here, sigma I equal to 1 to n and ith section computation, whatever the computation ith section. I divide my problem into n different parts. Each part, any part I represent as ith part. What is the computation for the ith part? Then summation I equal to 1 to n and ith part. If I add all the I, it becomes the net solution. If I talk in integral calculus, then there is a limit sign from begin to end, fx dx. This is the basic fundamental of integral calculus. What is fx dx integration from begin to end? What this is saying is that we integration means calculation of the area. If this is x-axis and this is y-axis, means function over x-axis, there is a curve called fx, and x1 to x2 means from here if I take a straight line, what is the area underneath it? That is fx dx from x1 to x2. This can be considered also as summation only. Means I divide this portion into n different parts. I divide this area, whatever area we are calculating from x1 to x2. This area I can divide into n different parts, where n tends to infinity. In summation, if I talk about the summation, there is no guarantee that n tends to infinity. But in integration, I can chop my area fx dx from x1 to x2 into n part. N tends to infinity. Each part is a sub-area, naturally. Each part is a sub-area. If I add all the sub-area, it gives the full area fx dx from x1 to x2. x1 to x2. Now someone can consider if this is x1, this is x2. Between this, what is the area? Now just divide this area portion into small vertical sub area. This is the vertical sub area. If this is the x-axis, this is a vertical sub area, another vertical sub area, another vertical sub area. If I add all the vertical sub area between x1 and x2, it becomes fx dx only. But number of sections we have divided n must be tends to infinity. This is also a summation. What is summation here? Summation I equal to 1 to n. Summation I equal to 1 to n. Where I talks about the section number. Where I begins from the x1 and it ends in x2. So I is from 1 to n. Where each section width is x2 minus x1 by n. I am converting integral calculus into the summation. Summation I equal to 1 to n, where each section width, if I talk about the area subsection, each section width is x2 minus x1 divided by n. I am converting x1 to x2 fx dx into summation. I equal to 1 to n fx into delta xi. This is also integral calculus one. This is the integral calculus summation I equal to 1 to n. Function over x belongs to ith section. First section, second section, third section. Okay, x belongs to ith section. Or I can say x belongs to x1 plus ith section with, we will talk about it. And then delta xi, what is the width of, if I this is x1, this is x2, I chop between x1 and x2 into n sections. Each section I'm describing as ith section. Any section I'm describing it as ith section. In that manner, the width of the ith section is delta xi. What is that width is that x2 minus x1 by n, because I have divided into equal width space. Okay, thank you very much. Then I can describe now it as summation I equal to 1 to n. I is section number 1, 2, 3, 4. Okay, and then fx function over x, x belongs to x1 plus the ith section distance from the beginning. If this is the beginning, if ith section is fourth section, then this width will be 4 into x2 minus x1 by n plus x1, because x1 is the beginning. So fx means x belongs to x1 plus width of the ith section from the x1. Okay, I believe it is all right. Delta xi the width means fx at x equal to I into delta. This is the this is the strip. Then I add all the strip. So in repeated summation, what we are talking summation to integration. In repeated summation, it is summation of I equal to 1 to n and whatever we have computed for the single part. Single part can be area, it can be a vertical line whatsoever, doesn't matter. It can be a single vertical line also. It can be an area also. But if I convert integral calculus into summation, it must be a subsection area. Area is must. If I go for repeated summation, converting the integral calculus into repeated summation, the repeated summation of the ith section, if I talk, ith section must represent one area that is required. Okay, but if I go for normal repeated summation, ith section may not represent an area. But in integral calculus, ith section must represent an area. Fx into delta xi is required. Okay. Now summation I equal to 1 to n. N must be infinity. Here in repeated summation, n must be infinity is not required. Okay, that is the difference. So someone would ask, if I go for the repeated summation, I equal to 1 to n, and I compute the ith section. If I convert this ith section into sub area section, and then I make n tends to infinity, can I directly convert it to integral calculus? Certainly. This is what the integral calculus. That should be the aim, to convert any summation of entirety into summation of sub area. That is required. If you convert any entirety into sub area and then make n tends to infinity, it will get converted into integral calculus. Anyway, we are talking about the importance of vector in calculating the ith part. Ith part can be anything. Okay, right now, okay, okay. So, okay, what is the discussion that we are pursuing? We are pursuing discussion that how we can compute the peripheral of a circle, peripheral of any curve. How we can compute the peripheral of any curve. To calculate the peripheral of any curve, we have many methodologies. One methodology is cut the peripheral into n different parts and calculate the peripheral of one part and then add it. Summation I equal to 1 to n and then peripheral of any ith section. If I divide this peripheral into n parts, then peripheral of any ith section. If I do so, then it will give the peripheral length of a circle. Another is that this is x-axis. If I take the circle, this is x-axis and this is y-axis. If this is x-axis and this is y-axis, Then if I want to calculate the peripheral, I divide the x-axis into n different parts. For each part on the x-axis, then if this is minus a, this is origin, then each part width is 2a by n. Okay, think this is origin. Think any ith section. This is the first section, second section, third section. This is the nth section of the division. Now take any ith section. If I take any ith section, this is the first part. This is the second part of the ith section. If I go up, then it hits here. So this is the it makes a intersection here. What is the length of this ith section? Ith section on x-axis, not here. So ith section on x-axis, if I go up, it will hit on the circumference. What is the length of the circumference of the ith section? If I know it, then I'll sum it for all the sections. Summation I equal to 1 to n. Summation I equal to 1 to n. And length of the parameter that belongs to ith section on x-axis. What is length of this parameter? Okay, length of this parameter. Then we saw the this is begin point, this is end point. I can represent it as a vector. I can represent it as a vector. This is the vector P1. This is the vector P2. This is origin. This is origin. This is point P1. This is point P2. This point corresponds to ith section on x-axis. I can draw position vector P1, P2. If I differentiate P2, P1, then it will give me another vector that will connect point P1 and P2. This is x1, y1. This is x-axis, y-axis. This is x1, y1. This is x2, y2. If I connect these 2 points, then I am connecting x1, y1 and x2, y2. Okay, then if I say that this is the length of this section, then I'll calculate the length of this vector, that is delta p, p1 minus p2. If this is p1, this is p2, p1 minus p2 or p2 minus p1, it will be vector that will connect point p1 and p2. If I get the magnitude of this vector, then I get the length of this section. But someone would say this is a straight line. This is a curve. Okay, let's proceed. Then summation I equal to 1 to n delta pi, change in position vector of the ith section. If I say like that, then also we calculate the length of the parameter. Okay, but it is a straight line, and here it is a curve. Let's say n tends to infinity. If n tends to infinity, then this curve will be very small, because if I take ith section here, if I take ith section here, it will be so small. If n tends to infinity, it will go up, and this curvature will be very small. In that manner, straight line and curvature, they will be similar. This is what I generally don't like. This is called approximation. But anyway, if it is approximation, then we did approximation model of the integral calculus also. Okay, integral calculus approximation we also did. What we did in integral calculus approximation is, what is fx dx? Fx dx is, if this is x-axis, then this function is fx. Then fx dx will calculate exact area between limit of the integration x1 and x2. I divide this area into n different sections. Each section has a width. Now, width is x2 minus x1 by n. What is the area of this subsection? Area of this subsection is function over x at this point. That is the height into width. But someone would contradict here, because that will give you area of rectangle. If you calculate height and multiply by the width, it will give you area of the rectangle which has a flat top, but you have a curved top. Okay, then take n tends to infinity. Divide between x1 and x2 into n part, n tends to infinity, so that it will be so small that its length into width will give the area of the subsection approximately. This is what people say. Similarly, there also will be. So now we have summation I equal to 1 to n tends to infinity, and then delta p of the ith section. If someone calculate delta p of the ith section, then he can calculate the summation. What is delta P of the ith section? If I take, okay, we will go again rubber gold. Okay, so what is the delta P of the ith section? Okay, if I take x-axis, if I take x-axis, this is the ith section. It goes up here. And what is the length of this vector? The length of this vector is delta P magnitude. What is delta P? X2 minus x1 I. What is P1 vector? X1 I plus y1 j. This is x1 I plus y1 j. This point is x1 y1. I'm taking I've chopped this x-axis into n different parts. I'm taking ith section. If I take ith section, it goes up. Then it hits 2 points. One point is x1 y1, another point is x2 y2. Now if I draw position vector, this is p1, this is p2. Delta P is this one. Magnitude of delta P is the length of this ith section. This is what we are saying. It will be exactly equal to the curve if n tends to infinity. Now we have summation I equal to 1 to n tends to infinity. Length of this curve, that is the length of this vector delta Pi, ith section, that is x, that is x2i plus y2j minus x1i minus y1j magnitude. That will be x2 minus x1i plus y2 minus y1j and its magnitude. What is x2 minus x1? That is delta xi. What is x y2 minus y1? That is delta yi. Means if I calculate magnitude, means if I say delta xi whole square, what will be the magnitude of this vector? X2 minus x1 whole square plus y2 minus y1 whole square square root. X2 minus x1 I can say width of the ith section. Then height of the ith section y2 minus y1 I can say. Now we have what is the circumference of the ith section belonging to the x? The circumference is delta x ith section whole square plus delta y ith section whole square root. This is we are going through the vector fundamental. If I add it for all n section where n tends to infinity, it will give the exact solution. This is what we are in the understanding of. Okay, can I convert into integral calculus? Integral calculus wants summation of I equal to 1 to n fx dx. This is what integral calculus wants, where fx is the height and dx is the delta xi. We have talked about it. Now how I can convert into fx dx? It is square root of delta x of the ith section whole square plus a square root of y square root of delta x ith section whole square plus delta y ith section of the whole square. Okay, it has to be in fx into delta xi. This is what is required. Let's take out delta xi. It will become a square root of 1 plus delta yi by delta xi whole square into delta xi. Now it is in exactly form what we want. Fx into delta xi. It can be directly converted into integral calculus. Now, what it will be? Now it will be limit x1 to x2 minus a to a minus a to a minus a to a fx dx. What is fx? Square root of square root of 1 plus delta yi by delta xi whole square into delta xi. Delta xi will become dx and delta yi by delta x will become dy by dx. Means square root of 1 plus dy by dx whole square in dx outside dx integration minus a to a, it will give the circumference of a circle certain as per the fundamental. See, mind blowing, we have started the vector fundamental, right? We took the 2 point to calculate the length of the curve. Then 2 point we described as a position vector. Then took the difference of the position vector. It came as like this, connecting these 2 points. Now I am trying to calculate the length of this vector delta p. And then if I my understanding is, yeah, I had this arrived because of I chopped the x-axis into n parts. If n tends to infinity, the length of this vector will be more or less same as the what more or less it has to be same as the curvature what is arisen from the ith section into the cut. Someone can try. Someone can try for the circle. Someone can try for anything. It will give the length of the curvature. Someone can try. But idea here is not go by this approximation. Is there any way that we can think concrete solution? I don't want to go by the fundamental of approximation. I want to use vector. People would understand vector is nothing but a methodology of approximation, because wherever I calculate the magnitude of vector, it will be a straight line only. Then I have to think about it is equal to the curvature if tends to 0. And is it vector a science of approximation? Certainly not. Vector is a science of completely accurate methodology. Then what is the problem? How we can proceed in a vector fundamental where it will be accurate? Okay, then we are coming to a fundamental called tangent. What is tangent? Okay, if I have a point here and I connect this from origin, this is radius of a circle. This is a position vector also. If there is a point here, this is x-axis and this is the origin. Consider, consider this is the origin. If this is the origin, this is point here, P. I can connect the origin to P, origin point to P. If I connect like this is called position vector. This point is x comma y. This is x, and on y-axis this is y. This point is x comma y. This position vector will be called xi plus yj. Xi plus yj means there are two energy sources here. One is going in x direction, I direction, and it has a strength of x. One energy is going in j direction and it has the strength of y. If I add both energy, it becomes xi plus yj. Xi plus yj. If this is origin, then this is x comma y. From origin, we are drawing a vector that is going like this, xi plus yj. This vector or energy is addition of two energy. One energy is xi, one energy is yj, and then xi plus yj. If I differentiate this, it becomes I plus, it differentiate with x, it becomes I plus dy by dxj. Still it is a vector. If there is a vector xi plus yj, if I differentiate this vector, still it is a vector I plus dy by dxj. What is that vector? That vector is, if this is the position vector of xi plus yj, it will resolve in another vector. It will resolve in, it will resolve in another vector. That will be, if this is touching point P here, it will resolve in another vector that will be tangent at this point. A tangent on a circle and radius, they are perpendicular to each other. That is a luck. But not required that every line tangent will be perpendicular to the position vector. Not required. Only in case of circle, but whatsoever. If I have a position vector and if I calculate the differentiation of position vector, it will result in another vector, and that will be that will be tangent at the point where position vector is lying on the curve. What are you trying to say? I'm trying to say, consider there is a curve formula is y equal to x square. This is x-axis, this is x-axis, and this is y equal to x square. This is the formula of this curve. This is y equal to x square. Now, if x is 10, then this is 100. Height is 100. If x is 100, then height is 100 square. If x is 2, then height is 4. This is the equation. If I take any point P here, if I take any point P here, that is x comma y, any point P here, that is x comma y. If I connect, this is origin. If I connect from origin that point x comma y, this is position vector of the point that is x comma y. If I differentiate this position vector, it will result into another vector. That will be at this point, it will be tangent to this line. This is tangent to this line. At this point, it will be tangent to this line. This line, tangent vector and position vector, they are not at perpendicular to each other. If I take at origin, if I take at origin, probably they will be in same direction. I believe so. If I take up, then position vector will be like this and it will be like this. If I take here, position vector will be like this and tangent will be like. They are not at perpendicular to each other. But if I differentiate a vector, then new vector will be tangent at the point where I am differentiating it. If I am differentiating at a point x comma y, where position vector is xi plus yj, then new vector that will result from differentiation is I plus dy by dxj. This I plus dy by dxj will be tangent at this point. That is the one fundamental. What is tangent? Everyone, no, means people generally they just say tangent, tangent, tangent. What is tangent? Okay, if I say this is x-axis and this is y-axis. Okay, now I have a line like this that is passing through origin. Okay, and I have a point here x comma y. Then what is tangent here? Tangent, anyone will say, oh, tangent will go along the line one. At this point, if you try to calculate tangent, it will go along the line one. Okay, understandable. If I shift this line up, line is here, then I shift it up, opposite. What is tangent at this point? Tangent will be again along the line one. Means if I have a straight line, tangent will go along the. What is tangent? This is the question. Tangent is a if I try to calculate tangent at any point, tangent is a line. Tangent is a line that go along the line at that point. That is tangent. Oh, what do you mean? If I take any point here, x, if this is x1 and height is y1, any point here x1 comma y1, if I take any point here, then tangent at this point is a line that will go along the line at that point. Okay, at that point along the line is this line, then you are talking tangent will also go along the line one. Yes, then they will be same. Line and tangent line, they will be same. Yeah, they will be same. Where they will not be the same? In case of curve. This is not a straight line, it is a curve. If it is a curve, then where is your line? If I want to describe your line in a straight line, then if I talk about this portion of the line is going like this. If I talk about this portion of line is going like this. If I talk about this portion of line, the line is going like this. Means everywhere, if I put something, some bolt inside it, that or any need inside it, then it will go like this along the line. Makes sense? If I put a bolt, nut bolt, if I put a bolt inside it, then it will exactly pass like this. At any moment, tell me the direction of the line. Oh, you want direction of the line at any moment, right? Because everywhere direction is different. If I take a straight line, if I take a straight line, if I put a bolt will pass through a line. That is a straight line. Everywhere direction is same. What is direction is same? If I take any point here, and if I say this is y and this is x, y by x is the y by x will tell the angle of the movement. At this point, this is y, at this point, this is x. At this point, the bolt is moving, and then it is moving in angle that is y by x. If this point is y1 by x1, then bolt is moving in a direction y by x1. But everywhere angle is same. That's why tangent coincide with the line, because line angle is everywhere same. If I talk about tangent, then tangent will talk about at that moment, what is y by x? Hope, we will talk more now. Now, if I take a curve line, then line is bending. Line is not a straight line. If bolt is moving like this, at any moment, if I say what is your angle, then I will say vertical by horizontal for time being. If this is point is y1 x1 y1, then y1 by x1 will be the angle of this line. Means y1 by x1. Y1 by x1 will be angle with the line with x-axis. Means at that angle bolt is passing. If bolt is passing here, then what is y1 by x1? The bolt is passing like this. Everywhere angle is different. Means tangent, if I talk about tangent is a line, tangent is a straight line that tells about the direction of line at any moment. This line direction of line is changing. Everywhere angle is changing with the x-axis. This point, if I take y by x, that will be different. If I take y by x, that will be different. Here, if it is 10, then y is 100. Y by x is 10. If it is 2, then y is 4. If it is y equal to x square, y by x is 2. Everywhere y by x is different. Means this proves that this does not have a slope with x-axis as constant. This is a variable line. At any moment, what is the direction of the line? That is tangent. At any moment, what is the direction of the line? Direction means angle with x-axis. At what angle it is at x-axis? If something demonstrates this, then that is the tangent line. A line, if I say at this point, line is moving at this point, what is its angle with the x-axis at this point? Angle with x-axis, if I ask, then angle with x-axis is 30 degree. Here, consider the angle with the x-axis is 30 degree. Means 30 degree is the angle. Then equation of the means if this line, if I'm moving a bolt along this line at this moment, angle of this line is 30 degree with the x-axis. Okay, now you have to write the equation of line at this moment, because every moment the line direction is changing. Every moment we have different line direction. At any moment, tell me the line direction. Any moment line direction will be tangent line. If I draw a tangent line at any moment, that line, whatever the equation of the tangent line is, that is the equation of the line at that moment in a straight line manner. Otherwise, we have y equal to x square. But y square equal to x square is not a linear equation. Y equal to a constant into x, that is a linear equation. Linear equation means a straight line. Tangent at any point is at any point, what is the direction of the line? That someone want to understand. Means if line is moving like this, everywhere direction of the line is changing. Everywhere means every moment angle with the x-axis is changing. At that moment, if I know the angle with the x-axis, can you describe at that moment what will be the straight line at that moment? Everywhere a straight line is changing. If I want to describe a curved line with set of a straight line, there will be infinite straight lines. Every moment a straight line will be different. That will talk about the direction of that curve at that point. That is called tangent line. How to calculate tangent line? If I have a straight line, consider I have a straight line. If I have a straight line, at this moment, this is x1, this is y1. At this moment, what is the equation of tangent? And what is the direction of this? Oh, direction means angle. Yeah, angle. Y1 by x1 will give you tangent of the angle. If this angle is theta, the tan theta will be y1 by x1. Okay, then theta is tan inverse y1 by x1 at this moment. Okay, then what will be the tangent? Then you know the angle now, right? Tan inverse y1 by x1. You can write your straight line formula. Oh, I know a straight line formula. I know. What is that? Y equal to tangent of the theta into x. Tangent of the theta is y1 by x1. So at point y1 by x, this is x1, this is y1. At point y1 by x1, the formula of the line tangent line is y equal to y1 by x1 into x, or y equal to mx. Makes sense? Any moment y1 by x1 will be constant, because angle is everywhere constant. One angle is set. Tangent talks about the direction of the line at any moment. Direction means angle will everywhere is same. Oh, understood. Equation of tangent at any point is y equal to y1 by x1 into x. I have taken one point y, but it will be same everywhere. Now I am shifting this line up. Now tell me what is the tangent at any point here where x-axis is below. Now here, if I take the equation of line will have some offset. Now y equal to mx plus some offset what we did. Consider this offset is 2. Y equal to 2 plus mx. What is mx? What is mx? Oh, I know mx. Now this is y1 and this is x1. So y1 by x1 is m. So y equal to 2 plus y1 by x1, y1 by x1, y1 by x1 into x. Wrong. This is not perfect. Why it is not perfect? Because this y1 by x1 is not giving the angle. This is making an angle with the x-axis. This axis I can take up, then this is the angle. But if I say y1 by x1, then it will talk about if I take a straight line from here to here, then that angle it is saying, well, this is not the angle of this line. What is the angle of this line at y1 x1? Okay, so calculating the tangent equation is y equal to mx, where m is y1 by x1. That's why I know. But how to calculate y1 by x1? If line is passing through origin, then I can calculate y1 by x1, that is m. But if it has offset, then y1 by x1 will not work. Then someone would say, why don't you do one thing? Okay, you take it to the origin and then calculate y1 by x1. Or you take a small offset here and you're calculating at point x1, right? Yeah, at point x1, go and hit here. Okay, at this point, take a little left and take little right. Means x1 minus delta x and x1 plus delta x, or x1 plus delta x. You take a small section here. For this small section, calculate the height. Then you will get local y by x. You want local y by x, not the global y by x. Global y by x will give you error result. Yeah, I want local y by x. Okay, local y by x. Now we have here, now we have x plus delta x or x1 plus delta x. For x1 plus delta x, what is the delta y? This delta y by delta x. If this is y1, then this is y1 plus delta y. y1 plus delta y. Okay, so this is delta y. So delta y by delta x will give the tangent of the angle at this portion. Now I can say what is the equation of the line? Y equal to delta y by delta x into x. But this line will pass through origin plus whatever the offset is. Okay, means if I calculate y by x, will it give really? Yes, anyone can try. Y equal to 2, that is the offset, plus any delta x, delta y by delta x into x, where delta x tends to 0. It should be very fine at that moment, at x1, at that moment. If I take a small section, then what will be the height? If you divide, that will give you the angle at that moment. This is the equation of tangent line. Will it work for the curve line also? We'll try. Okay, now for the straight line it will work because slope is same for the straight line everywhere. We put offset there, but if you put offset, we went to delta y by delta x. Let's try here. Okay, if this is a curve, if this is a curve, if this is a curve, then we are trying to find the equation of this line at any moment x1, y1. What is the line equation at this moment? If I describe that line as a straight line, that is tangent line, direction of the line, then can we find in that manner? Okay, if I consider a small section here, then what will be a small section y? This, if I take a small section, means if I cut this line portion into very small thin section, it would behave like a straight line. If I take delta x as very small, then delta y by delta x if I take. First fundamentally I tell. Okay, someone will say, why you are trying this? This line is passing through origin only, right? Yeah, it is passing through origin. Then take y1 by x1. Y equal to y1 by x1 into x. Like the way we took for the straight line. If it is a straight line, then I pass this straight line through origin. If it is through origin, then any point I take y1 by x1, whatever it comes, then I say y equal to y1 by x1 into x. This is the equation of tangent line at point x1 comma y1. It is also passing through origin, right? Yeah. Then at any point x1, this is the height y1. Then y1 by x1 you calculate. It is passing through origin. Okay, then y equal to y1 by x1 into x. What is y1 by x1? At any moment for y and x relationship is y equal to x square. It will be x square by x1. So it will be y equal to x1 into x. That will be the equation of a tangent line at that point. Is it really true? No. This is again not true. Why it is not true? Even though it is passing through origin. Because this is not a straight line. It is combination of straight line. It is a combination of a straight line. If I take many straight lines, if I take many straight lines, every moment of this line, every moment of this line is a straight line. It is combination of infinite straight line. If I add infinite straight lines, it will become a curved line. At this point, if I want to calculate the tangent at this point, it is this straight line, not this line that is going through origin. This is dummy. I'm this straight line is passing from here, not through origin. So I have to take delta x and delta y to calculate the tangent, the angle of the line. If this is a set of infinite line at this point x1, y1, that line is inclined at what angle from the x-axis? If I want to know, then I have to say delta x, delta y. Delta y by delta x is nothing but if delta x tends to 0, it is dy by dx only. Means if I calculate dy by dx, it will come in algebra. It will come in algebra like y equal to x square. Then dy by dx is 2x. If I go by y by x, then it will be x. Here it is different. If I say I want to calculate tangent, then y1 by x1, this is called division. Division will not work. If it is a straight line passing through origin, then y1 by x1 will work. Division will work for a linear equation only passing through origin. Division will not work for a non-linear equation even though it is passing through the origin, because it is set of linear equations. And at this point, linear line is different and it is not passing through the origin. Okay, consider that at any moment that line is passing through origin, then it may work, luckily. But no one will go for the luck. Everyone wants to go for the fixed thing. For a fixed thing, if you want to know the equation of a line at that moment, then you have to find the angle of that line with the x-axis. To get the angle of the line with the x-axis at that moment, I have to find the line. If line is there, then I know the line, then I can calculate angle immediately. Y1 by x1 is a straight line or delta y by delta. But if you don't know the line equation, you want to find the line equation, at that point, what is the straight line equation? At that point, you have to calculate delta y by delta x. Change in delta x brings how many change in delta y? That is dy by dx. That will be 2x. 2x. So if I want to calculate the dy by dx at any point x1, it will be 2 into x1. When x1 is 100, then dy by dx will be 200. If x is 4, then dy by dx will be 8. Means tan of the theta, tan of the angle that it will make, it will be 8. Tan of theta can go from 0 to infinite. If it is 90 degrees, then it is infinite. If it is 0, then it is a flat line. Okay, tan theta is 8. Tan theta is growing. For 100, it is tan theta is 200. Means the tangent line is becoming vertical time to time. Okay, this is the way we calculate the tangent line. What is tangent line? Tangent line is the actual line. Actual line. What is the tangent line? If I have a curve line and at any point I want to calculate the tangent line, what is tangent line? Is the actual line on the curve if I want to demonstrate the curve into set of straight lines. If a curve is a if curve is a non-linear algebraic equation, then how I can describe a non-linear algebraic equation in a set of linear algebraic equation? Then it will be set of tangent line. At that particular moment, how can I describe a non-linear line as a linear line at a particular point? Certainly, but that linear line will be tangent. Tangent describes the direction of a curved line at a particular point. What is the direction of that line? Okay, we'll proceed on this. can we use this fundamental of tangent in calculating the ith section, in calculating the ith section length of the curve? That will be perfect, not approximation. If we remember, we tried to calculate the ith section of the curve through delta p, and delta p was a straight line. It was not a perfect curve. Then we took n tends to infinity. But we will try now perfect. Okay, perfect. There, whatever. But at the end, it should come to the same if solution is perfect. Anyway, so we will use tangent methodology to calculate the perfect length of the curvature in terms of vector. Vector can be used to calculate the ith section length perfect. Not the ith section of the length is a straight line, then we do the approximation. To have that, we need a set of vectors. If I want to demonstrate, if I want to, this is x-axis and this is the ith section chop, it will go hit here. It is this section is there. This section is a curve line. If I want to demonstrate this curve line section through vector, then there will be set of vectors, set of lines. Vector means a straight line. Set of vectors I have to describe it. But set of vector I cannot describe in one vector. It has to be variable vector. Yeah, we will use algebraic vector. If I have an algebraic vector between these 2 points, then I have a one vector representation of this line, but that will be algebraic vector. If I know algebraic vector, then what we have to do? Okay, but we can represent a curve line through algebraic vector. That first I have to find. Then we will proceed, and then we will see that vector is a perfect sign. It is not a straight line and then think about a curve line or something like that. Please don't mind supporting us or mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.